Hey, Honors Algebra 2 students, this is going to be your second day on ellipse equations. You can take out your fast fact sheet that I gave you yesterday, and then hopefully that will, kind of reiterate some of the things we talked about. But you guys, these are your notes for May 7th, so put 5-7 at the top of your paper. There's no guided notes, no PDFs for you. This would just be done on a blank sheet of paper. Well, you're given an equation, and I'm going to tell you how you know it's an ellipse equation. And if you go back and you look at any of the problems that Mr. Clendena did for you on Monday or Tuesday, you'll realize that there is a little bit of a difference in this. Parabolas only had one letter squared. So, and we only did x squared. Y could be squared, but it makes a little bit something different. Circles had x squared and y squared, but they always had the same coefficient. Well, ellipses are kind of like circles if you think about it. Circle's perfect, but ellipse is elongated horizontally or vertically, so it's like an oval shaped. So it's very close to a circle equation, except they have different coefficients. So once I see x squared and y squared with different numbers in front of them, then I know it's an ellipse equation, and I have to get it to look like that fraction equation equals 1 on my ellipse fact sheet. So the first thing I would do is I would group, and what I mean by that is I always try to put my equation as an x group because I might have to complete the square for that. Then I'll put a y group, because I might have to complete the square for that, and equals my number group. Now, the numbers would just come together because they'd be like terms. So this obviously is not going to be separated by a comma. There's going to be plus or minus. And anytime I think I'm going to have to complete the square, I will leave blank spaces. But I first group them together. So I scan my problem and I'm like, all right, I'm going to put all the x's first. Luckily, there's only one of them, 6x squared. Then I'm going to put all the y's next for my y group. Well, there are two of them, so I actually just leave it exactly the same. And then the number group, well, there is just a number over there, 21. In the next problem, you're going to see me have to move things around and all that. But this one was actually set up exactly the way I like it. Now, you're going to see if you have to complete the square for any variable. You complete the square when you have the letter squared and the single letter. So this right here doesn't have a regular x, so I'm good with them. I'll keep it. But the y group, I have to complete the square for. Now, I cannot complete the square unless the coefficient is 1. Luckily, this is 1y squared, so I don't have to do any factoring or anything like that. So I put plus y squared plus 6y, and if I'm going to complete the square, I leave a blank spot. Equals 21, and I have to be fair. If I have a blank spot on the left, I need a blank spot on the right. Now we complete the square. Remember the process is we divide this number by 2, which is 3, and we square it, which is plus 9. Now, if I'm going to add 9 to the left side, to be fair, I have to add 9 to the right side. All right, my x group is still just 6x squared, but my y group is now a quantity squared because I completed the square. All of this work right here turns into positive quantity y, remember that number right there always comes after the letter, plus 3 squared equals 30. I'm getting closer. Well, I'm good, but I don't have a 1 over there. Now remember, if you want to go back and look at the video from yesterday, how do you turn a number into 1? You divide it by itself. So I will divide both sides by 30, but when you do the left side, you have to divide them both by 30. And remember, I promised you your fractions would always become 1 over something. 6 over 30 is 1/5, so I don't have to show the 1. And then 1 over 30 stays 1 over 30, so it's quantity y plus 3 squared over 30 equals 1. That is now ready to be graphed. I'm not asking you to do that today, but you will be expected to know how to do that, so check back your video. Your center would be 0, comma, -3. Your a value would be the square root of 5, which would be 2 point something. So you'd go 2 point something to the left and to the right. And then the square root of 30 is 5 point something. And you would go 5 something up and down. So this would tell me that the minor axis is horizontal, the major axis is vertical, and again, you could graph it out. But we're just getting the equation ready to go because we already learned how to graph them yesterday. Okay, we only have one more example today because these are a little bit more challenging. Again, email or send us something on Google Hangouts to help you out. Best way to, though, is show us your work, and then we can find your mistakes. So send us your work and say, what was I doing wrong? It just doesn't seem right. All right, so here's number 2. But now we're going to have to do a lot more work. We have 3x squared plus 5y squared plus 6x minus 40y plus 68 equals 0. All right, what I'm going to do now is that x group, y group number stuff. So I group all my x's first, and I find them. There are my x pieces. So 3x squared plus 6x. Now I'm going to go to my y group. 5y squared minus 40y. So it's plus 5y squared minus 40y. And then I'm going to put my equal sign, and I want my number group on the right side. Well, no matter what these two numbers are, you would just combine them. But minus 68 on both sides leaves me negative 68. Okay, I cannot get 1 on the right side until I got my parentheses squared, which means I've completed the square, but I kind of got blockers here. I can't complete the square right now because that's a 3 and it needs to be a 1. I can't complete the square right now because that's a 5 and I need it to be a 1. So make sure that you are looking at these as separate groups. And we're going to have to factor by GCF each group. And it's not really the greatest common factor because we want to leave the y's in there, but we get rid of the coefficient in front of the squared term. So I want to factor out the 3 only for this group. Now, I shouldn't leave the parentheses right there because I need to complete that square. So I'm actually going to erase that parentheses and put a blank spot and close it. But that's where my x group just became. I factored out a 3 and I'm going to complete the square. Now what number do you have to factor out from the y group is positive 5. So I bring out a positive 5 and I would be left with. But remember, I don't want to close my parentheses because I want to complete the square. And that equals negative 68. But I forgot something. If I'm going to put a number there and a number there, to be fair, I should put 2 numbers on the right side to counterbalance that. All right, so I divide by 2 and I square it. I divide by 2 and I square it. But if you remember when we completed the square in previous chapters, when there's factoring involved, you have to make sure that you multiply the number in the front and your blank spot for what you really did. I did not add 1 to the left side. It's 3 times 1. I added 3 to the left side. So this blank has to be plus 3. Same thing over here. I did not add 16 to the right side. The left side. 16 gets multiplied by 5 on the left side. So that would be a total of 80. So I plus 80. With that, all that work set up there, please make sure that you are always multiplying these for a blank and multiplying these for a blank when factoring has to be used. Okay, now I can get almost to my final answer. I have 3, and those 3 pieces, the perfect square trinomial, becomes x plus 1 squared. I got plus 5, that stays right there. But these three terms are trinomial, becomes y minus 4 squared equals, and then on the right side, I get my number total. Negative 68 plus 3 plus 80 is a total of 15. And I have one final step. For an equation to be ellipsed and to be ready to be graphed, I need equal to 1. So how do you turn 15 into 1? You divide by itself. And when you divide the left side by 15, you divide the entire left side. So you do it to both groups. And I would have quantity x plus 1 squared over 5, because 3/15 is 1/5, plus 5 over 15 is 1/3, so I have y minus 4 squared over 3 equals 1. And now you could graph it. The center would be negative 1, comma, positive 4. Your a value is the square root of 5, which is 2 point something, which would be left and right. The square root of 3 would be your b value, which is 1.7, I think, but 1.7 up, 1.7 down. So since the larger denominator was underneath x, it's elongated horizontally and not vertically. But again, that's all information that you should have got from your May 6th video. All right, you guys, all you're doing today for the 2 homework problems is you are putting it in center form. Now, if you really want to graph it and get a little extra practice, you can. Here are your 2 homework problems. Let me see if I can zoom in there. There you go. So put those in center form. Number 2 is actually easier than number 1. Have a great day. It's your boy, Mr. Pete.